Hello everyone, my name is Arturo Garcia, and today I will be talking about my logic gate project for electromechanical systems. In this project, our necessary materials are number 1, breadboard circuit, number 2, breadboard jumper wires, number 3, power supply module, 4, 2 NPN transistors, which helps the main function of the logic gates, 5 LED bulb, number 6, your 2 push buttons, 7 battery snap-on connector, 8 9-volt battery, number 9 2K ohm resistors, and lastly 330 ohm resistors. So what is a logic gate? A logic gate is basically a series of transistors connected together to give one or more output, with each outputs being based on the inputs or combination of inputs supplied to it. In the case of our circuit, logic gates will make decisions based on a combination of digital signals coming from the inputs we provide. Logic gates can be explained through the use of truth tables, like the one we see here below. Here we have our inputs on the left and our outputs on the right. So in this case, if our input is a high value, then our output is going to be a high value as well. Now if our input is a low value, then our output will be a low value. So today we're going to talk about a buffer logic gate. So this logic gate is pretty simple. You only have one input and one output, and they're both equal to each other. So if you have 0 input, then you're going to have a 0 output. Vice versa, if you have a high value input, then your output is going to be equal to your input. So here we have our buffer circuit. We can see that the LED is not on because we have a 0 input. Once we press the button as our output, the light will turn on. And that's pretty much how this logic gate works. So the way the current flows in this circuit is that the current will flow from our voltage source through to R1 into the switch, but when the switch is not pressed, the current is not flowing through to this transistor. And when the current will split, it's not enough to supply the LED with enough current to power on. But once we press the button, the current is going to flow through R1, and now that our switch is closed, the current is going to flow freely into our transistor and out the emitter. It'll come around back to the voltage source and then through R2 and to our LED to power it on, and it will just do the whole cycle over and over again. So the next logic gate is called a NOT logic gate, and it is similar to the buffer in which you only have one input and one output, but they are opposites in the sense that if you have a 0 input, you're going to have a high output. Now if you have a high input, you're going to have a 0 output. So what I mean by this is when I turn on the circuit, the LED turns on without me even pushing the button in the middle. But once I push the button, the LED will turn off. Now the reason this is that when the current flows from R1 to the switch, when I push the button, the switch is closed. So that means the current's going to flow into the transistor and out the emitter through the parallel circuit and back to the voltage source, and it will travel to the edge of the circuit and it'll go through R2, but since this channel is open, it will split into the collector of the transistor and it will go back and forth. But when the switch is not pressed like it is right now, the current is going to flow through R1, but the switch is not down, so the current's not going to flow. So that means it's going to go back, or it's going to split into the circuit into R3, and it will split back into this parallel circuit and power on the LED, and that's how it will turn on. So this logic gate is called an AND logic gate, and this one is different from the first two in that it requires 2 inputs in order to function. So the thing about this logic gate is that if you have a low input in both of your inputs, or say if you have one high input but one low, it will still not work. It will still have a low output. But if both of your inputs are high, say for in this truth table you have a 1 in A and a 1 in B, then your Z output is going to be a 1 as well. So if we power on the circuit, the LED is not on. And even if I press 1, it won't turn on. But if I press both at the same time, the LED is going to turn on. So the way this works is that the current, say if A, this is A and this is B, and B is on, but A is off, then the current's going to flow from the voltage source to R2, but it won't be enough to reach this transistor. And when it splits off here in R1 and into the switch that we have pressed, yes, the current will flow into this transistor, but this transistor is basically off. It won't allow this current to fully loop and supply the LED with enough current to turn on. But once both switches are on, this means that the current is going to flow from A and switch A to the first transistor, and it will basically loop and split into R1, which is B, through the second switch and through the second transistor out of the emitter into this collector of this transistor, and it will loop again to the circuit R3, to the 330 ohm resistor, and to the LED to power it on. Okay, so our final logic gate is called the OR gate, and what this logic gate is, it's basically kind of like the AND gate where you need two inputs, or where you have two inputs, but in this sense, if at least one of our inputs is a high value, then our output is going to be a high value. So in this case, both A and B are 0, and then our output's 0. So if both of them are low, then our output's going to be low. But if one of our inputs are high, then our output's going to be high. Now if both inputs are high, then our output's going to be equally as high. So when we power on our circuit, you can see that since both our inputs are low, then the LED is not on. So if I push one button, the LED will turn on. If I push both at the same time, the LED will still turn on. So the way the current flows in this circuit is, say if this is A and B and both of the switches are off, then the current is going to flow from the source through R2, and this switch is going to be off, so it won't provide enough current to flow. And if the current splits here into R1 into this switch, which also is off and doesn't provide enough current for this transistor, then it won't be enough for the LED to turn on. But say if one switch is on, say for instance this one, there won't be enough current into this switch, but in switch B, the current's going to split into this resistor and flow through the switch that is on and into the transistor and out this emitter through the parallel circuit, and it will flow through to the resistor and to power the LED, and it will split back into the collector of the same transistor. Now if both switches are pressed on, then this means it basically opens another path for the current to flow. So then this current, instead of being blocked, it will flow through into this transistor, out the emitter, and into the parallel circuit, and then flow all around the circuit. And here it will split evenly into this collector, and that's when the current will just be doing a bunch of loops around the circuit, but our LED will still be on once both are on. That's the end of my presentation. Thank you very much for watching.